live. I
Sure.
present like the funniest lighting combination ever between Fraser and me, where I am overlit in the
Yeah.
sunniest room in my house, and
Yeah. Yeah.
you're not in
Yeah.
the sunniest room in your house.
No, I'm trying to take advantage of the low light sensitivity of the camera.
Hmm.
And so I'm dealing with more kind of reflective lighting, and I'm trying to have it come from all directions as opposed to being sort of like something that's directly on my face.
Yeah.
I've been really unhappy with my lighting. And so I'm sort of taking it down to the foundation and starting again. But it's a work in progress. So I think I'm going to have a long conversation with my producer Anton this afternoon, and we will try and come to a happy balance. But this makes me happier than where I was at before. But we'll get there. I got to just mess with the ISO settings and the shutter speed and all that kind of stuff, as well as sort of put more key lights and stuff around.
Yeah, I'm gonna brighten you on my end as well, because like,
I can go further. I can go all the way. Hold on. If I just remember where these settings are. It's been a long, like I've just gone with the exact same ISO settings for a long time. I think it's this guy, right? Nope, that's not it. Really shouldn't be messing with it without being able to see it. One second, let me see. Hold on.
I'm glad you like my sunny room, Alan. Yes, Smithtown, this
800.
room is so bright, so very bright. This
Okay.
is
Let's see.
this
So that's 12. You tell me when you're happy.
that sit back. I can't tell because you're like right and yeah. Now I just need to center you.
Okay. All right.
I love that I can just drag you around. All right, you're now in the right place.
Yeah. Yeah, exactly. Um, okay. So I don't have my intro written yet. Give me one second.
So while he writes that, I'm going to warn all of you, you may hear me cough a scary cough. I don't have COVID. I caught bronchitis the stupidest way possible. So bronchitis isn't something you catch so much as you develop because you've irritated your bronchi.
Mm,
And I irritated it by not thinking through the fact that I'm allergic to tomatoes. And my husband made tasty, tasty pasta with tomato sauce that I did not taste, but I smelled. And the act of smelling the tomatoey goodness pissed off my lungs. So he made a big batch for himself, and I spent the week trying to figure out what I was into that I was allergic to, and I was like down to living on edamame and chicken nuggets. And then I realized, oh shit, it's the tasty smells that are doing me in. So I
wow.
now have bronchitis from tasty, tasty smells. I'm not even allowed to smell the good things anymore.
That's amazing. Um,
Yeah, it's ridiculous. It's absolutely ridiculous. He took it in stride and he's like, "Okay, I will only have pasta when you are traveling." Um and now we have even more air filters than we had in the past. Yeah, it's ridiculous. So, yeah, I have all of the tea to get me through hopefully without coughing. Dave Killians is like, see, I told you that we need to fear killer tomatoes. Yes, actually, for me, tomatoes are killer. Uh, Bobo Bilio, drying ghost peppers in the oven was definitely a mistake, my friend. That was how you hurt yourself. But ghost peppers, I approve.
um, so you're not allergic to soy though. That's good.
yet. It's on the list of things I will eventually lose because the protein that I'm allergic to, over time, I'm going to get more and more sensitive to. It's one of these every experience makes you more sensitive kinds of deals.
Yep.
And the protein exists in soy just in very small amounts.
That's what I was wondering, because a lot of the times when people start to become allergic to things, soy goes, gluten goes,
Yep, both are on the list of things
dairy
I'll eventually lose.
goes.
Already,
Yep.
that one I was born without. So,
Yep. Yep.
but yeah, it's what's called latex fruit syndrome, and there is a protein that exists in natural rubber, and it's in like pumpkin skins, the flesh of tomatoes, and all the other nightshades. It's in so many different plants.
Yeah.
So it's a great diet plan.
Vomit and be on the toilet all the time.
Well, so that
unable to eat
actually
any food.
it causes asthma and massive allergic reactions. So anaphylaxis, not vomiting. I am not a fan of vomiting, so I guess coughing is better. But yeah.
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 All right. Let's begin and do our job, and then
Okay.
we will. Um, yeah. So let's do our show, and then I think we should chat about what's going on with NASA.
Oh, God.
Yeah. Yeah.
Assuming it
Yeah. I think
stays
people.
constant over the course of our episode.
Well, that's the problem. So,
Yeah.
I mean, I think the reality is that we don't know. Everything is so super in flux. But I think we should at least chat about the flux.
Yeah.
And as well as what's happening with NSF. I mean, what's happening with NOAA, what's happening with NIST, what's happening with DOE.
Yeah.
Like, there's a lot of shenanigans
Yeah.
currently
Okay.
going on right now.
I am pressing record on the video. I am losing where the button is to press. There it is. I have pressed record on the audio. Everything is recording on my end.
Astronomy Cast, episode 745. How do we know when asteroids will attack? Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I am currently dealing with some allergy situations. So if you hear
Right.
me coughing, I'm not sick. I just have stupid allergies. But yeah, I have never been more grateful to all of you on Patreon as we watch everything going on. I've had all of my colleagues like struggle with funding and stuff. So
Yeah.
Patreon people, you allow me to wake up a little bit less scared of my inbox. So thank you.
Yeah, I have the same, like I have a different, as a Canadian facing down tariffs from the United States and all the disruption that's going to be happening. I have the same ability to breathe easy thanks to everybody who has already become patrons. It's kind of amazing at this point how stable I'm able to make Universe Today, and like a lot of writers are coming out of the woodwork and saying, "Hey, Fraser, do you have any more work?
Yeah.
Stuff's drying up." And I think that is now going to accelerate. And I want to save them all, but I can't. So yeah. So for those of you who have already become patrons of either Astronomy Cast or Universe Today or CosmoQuest or all three, thank you so much. For those of you who are on the fence and kind of going like, "Oh, is this it? Is this the time? Is this when I directly support the creative work of the podcasts and the media that I really enjoy?" Yes.
Yes.
Yes, this is the time. This is the moment. We've all admired your stoicism from afar, but now you need to jump in and you need to help and not just us. I mean, we've already been supported in
Yeah.
large part by patrons and sponsors. We've been very good, but there's a lot of channels out there. I think about all the stuff that's run by PBS, the stuff that's, a lot of educational content that has some level of financing through, various government grants and things like that. They're going to get massacred shortly. So think very carefully about how you consume content, which channels you are most grateful for, and then figure out how you can support those creators directly with, if you watch a thing and you love it, support it directly, because if people don't do that, then that thing will just disappear. And it will be replaced with AI slop. It'll be replaced by a substandard version of it. And this is the spiral that we are now approaching. And so I think, for both of us, I think we're going to be able to weather this. A lot of places out there aren't going to be able to weather this. And so just now is the time. Contribute directly to the content that you find wonderful. All right. I'm sure you've heard the news. Asteroid 2024 YR4 has a tiny chance of hitting Earth in 2032. How do astronomers discover these dangerous asteroids, measure their future impact risk, and track the changes over time? When should we panic? And we'll talk about it in a second, but it's time for a break. And we're back. All right, Pamela. So before we start talk about just how this all works in general, we are in the late February 2025, and we can give you sort of a status today of YR4, and then we will begin to dismantle the whole proposition and move forward. So where do we stand today with YR4?
So as of 1:16 p.m. on February 20th, that is in Central Time, and these numbers are changing as data gets reduced and understood.
Hourly.
Exactly. We are sitting at a 1.5% chance of the Earth getting impacted and a 0.8% chance of the Moon getting impacted in 2032.
Right. December 2032. And what we know about the asteroid, it is probably about 50 meters across, could be as big as 80 to 100 meters across. The most accurate number crunching right now tells us that it's going to come within about 160,000 kilometers of Earth, which is close.
It's closer than the Moon, further than the geosynchronous.
Yeah. Geosynchronous is say 35,000 kilometers. The Moon is, on average 400,000 kilometers or 384. So it is less than half the distance from the Earth to the Moon. Now you mentioned, it's funny because you mentioned 1.6% chance of it hitting Earth. And yesterday, that we're recording this, it was 3.1. Yeah, it had already got up to 3.1. And then today we got this lowering of the odds down to 1.6.
It's actually 1.5 now.
1.5 now. Okay.
Yeah. So I'm looking at the NASA
we started recording
Century.
This episode.
Yeah.
Yeah. All right. So let's first. So that's the situation, and then let's chat a bit about worst case scenario.
Okay.
Let's say that a 50 to 100 meter asteroid did strike the Earth. How bad would that be?
So to put the size of this into a perspective that is easier to understand than meters, this is the size of a 747, give or take. But because of the amount of energy it impacts, pun intended, as it blasts towards us with a really high kinetic energy. If this thing was a solid iron core, we're looking at something like the Barrington crater, Barringer crater, the crater that's in Arizona. More likely, this is something that's going to go boom in the atmosphere, and we're going to end up with a Tunguska-like event that just flattens a region. Now, this is what's called a city destroyer for small enough values of city. It's bad, but it's the kind of thing that since it will have a really good approach in 2028 that will allow us to get an extremely accurate orbit, we will either be able to say we are going to move that and move it,
Right.
or
We're going to talk about that later on in the episode, because
yeah,
that's not going to be as simple as we hope.
True. But it's also the kind of thing where we could evacuate the necessary parts of the planet that would either be a land area or a whole lot of shoreline if it's slated to hit the oceans.
Yep. Also part of the conversation that I want to have later.
All right.
Mitigation. Yes. But the point being that you say city killer. So
Yeah.
if it does hit a city, it is like a 20 megaton
Go boom.
nuclear weapon going off in the middle of a city.
And it's either going to be an air blast that causes things to go flat, or
which is
it's
not
going
great, not good.
No, or just a direct, we're going to smash and directly impart the kinetic energy into the surface of the planet, which is actually a bit worse.
Right. And if it hits the ocean, also not great, because then it can cause localized tsunamis which can inundate the shore. So Chelyabinsk was, I think, a 17-meter asteroid.
Anything below 20 meters is going to do no worse than blasting out a whole lot of windows with localized damage, the level of we shall dent up your car or put a hole in your roof.
Yep.
But it's the kind of stuff that apparently also Starship will cause if you are beneath a starship that explodes. So pick your danger.
Don't do that. Yeah.
No. So it's the kind of thing that is a apparently acceptable level of danger. And if you get far enough below 20 meters, it just burns up in the atmosphere. We are lucky enough to have this super thick atmosphere that frictionally heats and destroys a lot of falling rocks.
Yep. Now, I want to talk about how astronomers find these things and figure out those probabilities, but it's time for another break. And we're back. So how do astronomers find asteroids like this?
We are very good at recognizing asteroids could strike. The dinosaurs had a really bad day. We do not wish to have the same experience the dinosaurs had. So we keep developing new surveys, new telescopes. Currently, the leading asteroid finding systems are the Asteroid Terrestrial Impact Last Alert System. This is ATLAS. It is a robotic astronomical survey that is out there basically looking night after night with half-meter telescopes to see what specks of light are on the move. And it was ATLAS that discovered YR4 on December 27th, a couple of days after its closest approach to the Earth. And based on how the specks of light are moving, we start to calculate orbits and then do a couple of different things, both getting other telescopes around the world pointed at these objects to confirm the orbits. And folks also start going through archival imagery, looking to see if they can confirm or deny past locations of these space rocks.
And, we've been chatting about this, I guess, in the science communication community. The news media has been reporting this. I feel like we've been on this for about 2 weeks.
Yes.
At this point. And when it was first found, it was a 1%, and then it was 1 point whatever, and then it was 2.3, and then it's 3.1.
3.1.
Yeah. So why has that number been?
I had a error message come up. Hold on, I have to type something in to placate wire loopback, or your audio probably already sounds terrible. Hold on, everyone. I am working to fix this. I am so sorry. Shoot. I had to perform a lobotomy on one of my computers, and apparently I missed typing in one of the things. One of the side effects of being a software developer is occasionally your computer is just like, no, man, I don't know what you're trying to do. That was wrong.
That's a bridge too far.
and they just fall over. They just fall over. Okay, I have to figure out what account I was in when I purchased this. Sorry, everyone.
Oh, wow. You have to renew your... Okay.
We'll have to figure out which email account has the, there it is, has the license key on it.
You hadn't put the license key in. Okay.
Yeah, that's, so I downloaded it.
People are saying, yeah, there's a lot of background noise. Okay.
Yeah, it is purposefully adding noise to make sure I remember I need to type in this code.
Of course.
All right, so can folks confirm that the background noise just went away? I'm only seeing my fish tank in the audio.
Sorted. Okay.
Okay, cool.
His comment.
Sorry.
Okay. All right. Yeah. So I asked you, why is the percentage going up?
So this cool adventure we've been on, where it was getting more and more and more, ever so slightly, likely to hit us. I have to admit to being Team Asteroid. It was because
I live on this planet too, Pamela.
I understand.
You can't solve an asteroid. You can't use an asteroid to solve all your problems.
I wanted to move it. I wanted to have an
right.
excuse to move it.
All right, we'll get to that.
All right. So, Team Asteroid. So what had happened was they calculated what are all the possible orbits that could fit the observations we have right now, which are kind of noisy, kind of not ideal because the timeline is too short. And then they started going back through archival data and saying, okay, this is an excellent orbit. Was the asteroid here? Shoot, it wasn't. When you don't find the asteroid along the good orbits, that eliminates the good orbit possibilities and increases the bad orbit possibilities.
Oh, interesting. Okay, so they find the asteroid and they find its trajectory, and then they go back through archival data to see if that essentially you can run that clock forward or backward and then see if it was in one of those things. And if it isn't there in the safe ones, then you're left with the unsafe ones.
Exactly. And so they'd found it in Subaru archives. They were looking in other archives as well. And it wasn't in any of the good places. The asteroid did not go to the good place. And because we don't have complete coverage of the sky every night across all the decades, especially not with the big telescopes capable of seeing the small rocks, all we could say was these good orbits are eliminated. We can't check the other orbits and we can't check the bad orbits. So here we are with the increasing probability of impact.
I had no idea that was the mechanism. That's really interesting. Okay. And so why then is the chance going down? Are they also not finding it in the bad orbits?
Sorry, my lungs decided to rebel at that moment. Again, allergies. I not COVID. So the moon got in the way. There was this window of time where, because we had a bright moon in the wrong part of the sky, it was just not possible to get the kinds of data that would tell us, no, we're safe. So now that the moon is back down to a quarter phase, rising at midnight, they're able to get more data. And that more data is giving us a better and better outlook for the future. Now, time has been granted to Andy Rivkin and his team to go ahead and use the James Webb Space Telescope to look at this asteroid next month, which will be March as of when we're recording this in February. And that will hopefully tell us how big the asteroid is, further refine the orbit. And right now, like I said, we're at only 1.5%. So it's still a Torino scale 3. Keep your eyes on it, folks. Be alert. But it will probably go down.
Right. That the Torino scale, this is that essentially asteroids of concern. If they're bigger than about 20 meters, then they get to, and they have a chance of hitting Earth at some point in the future, then they get to go on the Torino scale. And then the question is, what are the chances? What is the scale of the impact? And then you get a placement. And I think the highest ever was Apophis at like 4, and then it lost its ranking and went back down to 0.
Yeah.
And now Wire 4 has taken a nice solid 3 on the Torino scale, but we will expect almost certainly that it is going to drop back off the scale, and we're going to have to look for something else to be the dangerous asteroid of the future. All right. So next, I've been promising, I want to talk about mitigation, and we will talk about that in a second, but it is time for another break.
And I'm going to cough, and I'm going to mute before I do it. Sorry, everyone. Lungs.
And we're back. All right. Now I will allow a conversation about the mitigation of Team Asteroid. Let's say that, in fact, the numbers go higher and higher and higher, and it gets to a point where space agencies are concerned that there's a pretty good risk that this is going to hit us or come dangerously close. What could we do to stop this?
Well, we know, thanks to the DART mission, that we do have the ability to slam heavy objects into space rocks and cause their orbits to change. And from beginning of construction to launch was only about 3 years for the DART mission. So we have time, even if we wait until 2028 to figure out just how bad it's going to be, we have time to launch something to slam into it and move it. Now, I'm hoping that we don't wait until 2028 to figure out if we're going to start launching missions. And what's cool is there's lots of different possibilities. We were already starting to think through, how are we going to observe Apophis in all of its glorious detail when it comes back past us on April 12th, 2029. Apophis is a larger asteroid. That's how it made it to level 4 on the Torino scale. It's going to be so close to the Earth on April 12th, 2029, that we're going to have weather satellite images looking down at our planet from geosynchronous orbit that show an asteroid passing between those weather satellites and our planet. It's going to be a daytime visible object. It's kind of awesome. You'll be able
to walk outside and watch it go by.
Uh-huh.
Yeah.
Uh-huh. Now, for us, no, we're on the wrong continent.
Right.
I'm probably going to have to travel for this. Like, I feel obligated by the universe to go see this with my own eyeballs.
Wow.
But it's
like binoculars in the right part of Earth, watching it go by. It's going to be a few tens of thousands of kilometers, going past the Earth. But and it's big, way bigger than Wire 4. Like, Wire 4 is small and so of less concern. But let's say that we wanted to quickly accelerate the construction of a spacecraft. Mm-hmm. We launch it. When is the best time to do that? Do we do this now before it does that flyby in 2028 and gets its orbit tweaked? Or do we wait until 2028 when we know we have a better idea of what its orbit is going to be? And it's close, so we can reach out and smash into it.
So you want to try and deflect something as early as possible to give the effects of what you do the greatest opportunity to propagate through time. If you think about it, if you deviate a bullet just a tenth of a degree and you're a couple of feet away from someone, please do not do this, a couple of feet away from a target, you're still going to hit the target. But the further away you are, the more that deviation causes you to be more and more off center. So our planet is a whole lot bigger, but the chances of impacting require at a great distance for the accuracy of the trajectory to be just so. So the further away in time you are, the more the change you make has a chance to keep an impact from happening. I would personally say wait until we get the JWST data. This is what Andy Rifkin was saying is definitely currently NASA's discussion. Wait until we get the JWST data. Based on that, figure out what kind of a mission makes sense. I think we definitely need to plan something to chase this sucker down and observe it. Unfortunately, 2028, it's on an elliptical orbit. Our next closest approach, it's going to be tens of millions of kilometers away, which is not friendly. But we should definitely plan to launch something and be prepared for anything. Let's do science, people. Let's do science.
Right. I mean, it's an incredible opportunity to watch how the gravity of the Earth deflects the orbit of an asteroid when it's doing this flyby. It's the same priority that you're getting with asteroid Apophis with the updated version of OSIRIS-REx, that it's going to be following Apophis. It's going to watch as this asteroid gets deflected by the gravity of the Earth. And that's going to tell it about the composition of Apophis. If we could do the same thing with YR4, then we'll have 2 data points. Watching as these asteroids are deflected by the Earth teaches a ton about this. What are the risks? I mean, if we attempt a deflection of YR4, how could it go wrong?
Well, there's always the possibility that the spacecraft goes stupid, and instead of making it less likely to hit us, it instead makes it more likely to hit us. This is why you don't try and deflect something that isn't already going to hit you.
Right.
Because if it's already going to hit you, pretty much however you deflect it, it's going to miss you. If it's just going to come uncomfortably close, there's the chance that you take it from uncomfortably close to a direct hit. So do not try and move something that's not already going to hit you.
And the other possibility is that we fragment it, that we smash into it, turn it into a hail of particles, and now each one of those enjoys its own risk chance of hitting Earth or not. And so you're actually sort of turning it into a shotgun blast for that next orbit.
Now, the thing is, this is a smaller object. Like I said, it's give or take the size of a 747. Anything under 20 meters is not that big of a deal. So if we take something that is 80 meters across and we fragment it, as long as those pieces are under 20 meters, we're just generating a lot of heat, which is annoying and problematic. But we already have a lot of heat hitting the atmosphere from other space rocks.
Right.
I'd rather fragment something this small than not, I guess.
Right. And I know that there's a great article from Ethan Siegel that came out just a couple of days ago where he did some of the math, and it wasn't as satisfying as I was hoping. That even if we build something like DART, or maybe even like a super DART, something that's like 1,000 kilograms, we slam it into this asteroid as soon as possible, we just get a reduction of the risk by something that becomes a lot more satisfying. We knock away the 1% chance down to 0. We knock a 3% chance down to 1. It's not like we know that we're going to make this dramatic change, and it turns what is a risky spacewalk into something that is absolutely safe. And it's assuming a perfectly elastic collision. All of those still don't get you are 100% safe now. They get you are safer.
One of the cool things about these is it's not just a matter of, is it a elastic or inelastic collision? Is it a collision where the thing you strike it with sticks or bounces off completely and transfers all of its momentum? As we discovered with the DART mission, if you hit something that's going to fall apart, the fact that you have a bunch of material flying away causes the main chunk to accelerate away even faster. So you have this neat additional way of causing things to be on a less deadly trajectory. Now, again, you don't want to move something unless it's directly going to hit you, because the probability that you're going to make things worse is non-zero. If it's already going to hit you, you're probably going to make things better. So pick your battles.
Right. So right now, should you panic? Absolutely not.
Now,
When should you know to panic?
2028.
2028. All right.
Yeah.
So you're gonna have to wait, and we're gonna update you as we get closer. Either when it goes completely down to zero, and even they know the 2028 flyby is going to be fine, but after 2028. So we'll tell you when to panic. But until then, please don't panic. Don't worry. This is a tremendous science opportunity, and it's a great example and don't let Pamela's apocalyptic fantasies,
I want to move it. I want to see the world come together.
Yes.
To cheer on the little spacecraft that moved the space rock. I want global science.
Teams. So there is a team from the European Space Agency that's already come together to develop a working group to think about this, and a separate team from China that is doing the same thing, and they're already having collaborations between the two groups. And so we could absolutely see, no matter what, some kind of spacecraft, maybe a international collaboration, going to check it out as a scientific interest, or to actually move it. And so, so stay tuned. We will keep you posted as progress continues. All right, Pamela, thank you so much. And what have you got for us now?
I just want to take this moment to say thank you to all of our patrons out there. And this week, we would like to thank Abram Cottrell, Alexis Bore, Anthro Bart Flaherty, Brisnick, Brian Cagle, Burry Gowan, Daniel Donaldson, Daniel Knighton, Dwight Ilk, Felix Scoot, Galactic President, Scooperstar, Mix Scoops a lot, Georgie Ivanov, Greg Davis, Greg Vield, J. Alex Anderson, John Baptiste Lematne, Joanne Mulvey, Jonathan Poe, J.P. Sullivan, Just Me and the Cat, Kim Barron, Les Howard, New Zealand, Marco Arasi, Matt Rucker, MHW 1961 Supersymmetrical, Mike Huzi, Nick Boyd, Paul D. Disney, Paul Esposito, Pauline Middlelink, Peter, Philip Walker, Planetar, RJ Bask, Robert Cordova, Ruben McCarthy, Scone, Sergey Manilov, Simon Parton, Stephen Miller, Tim Garish, and Zero Chill. Thank you all so much. And if you too would like an opportunity for me to mispronounce your name, I am so sorry,
you really
everyone.
Want that. Thanks, everyone. And we'll see you next week.
Bye-bye. And then they saved.
So I know you have the Zoom Pro, right?
Uh-huh.
Okay. So we were doing a meeting. My wife has it as well. And we were doing a meeting with some of her friends, and we were trying to play bird songs from different parts of the world to each other. And we couldn't.
You have to switch on the music version. You can do it. You just have to go into the settings and fuss around.
But what was incredible about that was how good it was.
Yeah.
Like, we couldn't play birdsong. We couldn't even clap and hear each other clapping through the Zoom meeting.
Yeah.
Like, people were like, so I was like, okay, can you hear this? And I was clapping, and someone was going, you're just fake clapping, right? I'm like, no, I am actually clapping. And it wasn't coming through. Like, whatever they're using to do noise cancellation
really good
and remove background audio is now perfect.
Yeah.
And I don't know which version. Like, are you running either of those?
I'm running Zoom Pro, and it is.
So are you running the noise cancellation? So let's see. Okay,
right now I am.
Watch this. Okay, watch this. So let's see if this works.
It's totally gone. Totally gone.
Isn't that crazy?
Yeah. That one,
Yeah.
it picks up a little bit more. I don't know why.
Okay.
And if you try the new Adobe podcast, it's web-based, which is annoying, but it has background noise suppression like nothing else. It's scary good. And as someone who owns dogs, this is a miraculously awesome thing.
Yeah. Yeah. Your dogs are gone now. Yeah.
It's
Yeah.
glorious.
So in fact, we were doing this meeting and somebody was saying, "Oh, sorry about the dogs. The dogs are
Yeah.
barking at the mailman or whatever." And we're like, "There's no dogs. We hear no dogs. There's no sound. Everything's perfect." And in fact, it's even like you clearly can see it's cleaning up bad microphones. It is leveling the audio so everybody hears roughly the same thing.
Yeah.
Whoever is at Zoom working on that technology, they have nailed it. Amazing. Yeah. And like I have a low opinion of Zoom. And yet they crushed it.
And what gets me is in order to correctly remove the background like that, while someone is talking, they have to be able to suppress the background and then fill in those wavelengths again. So it
Yeah.
has to actually be AI driven to be able to know how to fill in the wavelengths they're removing.
In real time.
Yeah.
Yeah. Yeah, it's bonkers. All right. Well, we got a couple of questions, but I think we should chat a little bit about what's happening with NASA, with science funding and things
Okay.
like that. So we will attempt to have the least political
Yeah.
perspective on this, but also try to provide as much clarity and news as we can. So obviously, we have seen the very Doge and the various policies and stuff where this group is sort of working their way through. We saw USAID, as Musk said, thrown into the wood chipper. We've seen the fork in the road email where all government employees have been offered a buyout to not come into work anymore. And then we have seen the layoffs of probationary employees across multiple agencies.
And
so
let's take a
far.
moment to define what that means, because a lot of people, so sometimes in a company, if you screw up one too many times, you get put on probation, you
Yeah.
get a PIP plan to improve performance. This is not that. So with the federal government, pretty much every position has a certain period of time during which it's a no harm, no foul. We're making sure you fit the position. Probationary in terms of you are new and therefore you're on probation because you're new.
Right. But one sort of tweak is that I hadn't realized, but is that you can get a promotion and you're back in probation.
Yeah.
So you're seeing people who have been at, say, the department of whatever, for 20 years, and they've recently been promoted to a new position, and then they've been caught up in those layoffs because they are newly in this new role.
Yes.
Yeah.
And so people either switching which agency they're in, getting a promotion within the same agency, people who are new to their positions. So anyone who hasn't been in the exact position they're currently in for 2 years or longer, and they actually went in and changed people who had contracts that said probation was only 1 year long. They went back and they changed that to 2 years so that they could fire them. Now, what is opening this up to lawsuit is the letters that were sent out to fire people in many cases, perhaps all cases, I don't know, said that they were being fired for performance reasons.
Right. They were doing a bad job that violated the performance clause of their contract.
And so you have people that were receiving directors' awards, people who'd received only exceptional evaluations, being told they were being fired for poor performance where that wasn't documented.
Right.
And so that's now opened the government up to lawsuit and
and we'll see how that's all going to play on the courts.
Yeah.
So then we've seen this sort of rolling wave move through various agencies. So it went through the Department of Energy, which is, has some stuff that are related to space exploration and
Yeah.
science, but also is responsible for looking over the nuclear stockpiles, developing the plutonium and so on, that kind of thing.
Yeah.
We've seen it go through the NIST, which is the standards and time, which requires, you know, atomic clocks, things for science as well. We've seen it go through the National Science Foundation, where people are reviewing various grants and science proposals, in addition to the that's on the the people at NSF, but that's in addition to all of
Grants getting
all the
defunded.
grants that are getting funded, and then that's in addition to we talked about this last week about the what do you call it, the fixed
DEIA.
no the fixed expenses that are
Oh, the
right.
overhead costs.
The overhead costs, yes.
Yeah.
You've got this sort of the universities are not allowed to ask for as much overhead costs, but also a ton of various grants have just been stopped. And obviously, if you're a researcher who is expecting to be able to take a salary and be able to pay the salaries of the people who are working in your university, and now you're being told to no money for a while, you're gonna
Well,
that stops your work and
so
that stops your position at this job.
there's three different issues going on. So first you have all of the probationary layoffs, and that's been moving through agency by agency by agency. The other thing that you have is the abbreviation is RAH. I don't remember exactly what the abbreviation stands for, but what it means is they're now also going through and firing people who they feel their jobs are no longer necessary. So there was an additional 168 program officers from the National Science Foundation who lost their jobs yesterday.
Right.
So it's more than just the probationary people. Then with the funding, there have been court orders to reinstate funding that are getting flat out not followed. So the legal system is currently trying to figure out what to do with that.
Right.
So you have companies, including not-for-profits, including universities, that had good faith efforts completed that now can't get money on their federal grants and contracts.
Yeah.
Now, the additional thing that hit today is there are a lot of services that get paid for just on credit cards. That's kind of just how things happen. People have different spending authority, and money's constantly on the move. And today, DOJ locked down all GSA credit cards to having a $1 spending limit. So they're basically saying no more money can be spent through any of the normal processes, and all new expenses must go through this.
Right. So if they're using if they're using Zoom, if they're paying for a credit, if they're paying for tickets to upcoming conferences, if all that stuff is all now not possible, and so it makes it difficult to pay for ongoing expenses. If you're paying for, if you're transferring samples, that's
just mailing stuff.
Yeah, just mailing stuff. And the one that I think everybody is fairly concerned about is NASA, and so about a week ago, we got some scuttlebutt rumors that this whole process was going to start making its way through NASA. And last night, to Wednesday night, we got the announcement that Ames was the first on the chopping block, and that they were getting, all the probationary employees were getting let go. And then just a few hours later, this morning, there was a stay, and so that was rescinded. And so now, currently, apart from the people taking the buyout, nobody at NASA is getting laid off or fired for cause, right?
Now, there are people who are starting to retire because they don't want to be party to what's coming.
Yeah.
The most recent scuttlebutt I've gotten is that it will actually hit Saturday. And there's going to be a massive restructuring at NASA.
Right. Right.
One of the more interesting rumors, and unfortunately I haven't been able to confirm this, is that there are forces outside of Douche who have the ear of the right people who are saying,
You call
no,
it
dude.
douche.
Yeah.
So, right. And I know, in fact, specifically that we've got potentially even Jared Isaacman, and we don't, this hasn't been confirmed, but, as
Right.
potentially the new NASA administrator, he's been asking for some time to take the role and
Yeah.
then attempt a more light touch to bring NASA in line with the goals of the administration, as opposed to this sort of more general hack and slash. But and so we literally have no idea, but we know that there are like the Artemis missions are like, again, the on the one side, the Artemis missions could just get canceled.
Yes.
Right,
And
that's one possibility. Like, that's one possibility that is currently being floated around. And again, we can't confirm any of this yet, and no action has been taken. It's very frustrating because my writers keep going, "What can we report on?" And I'm
and
like,
we can't confirm
"We
these
can't
things.
confirm anything yet, and nothing has been done specifically with NASA." And so I'm like, hold,
Yeah.
right, until something has been done that we can then go, okay, here's what's actually happening that we can report on. And so if you're wondering, like, why isn't because, like, it's like there's some great people. NASA Watch is doing a terrific job of staying on top of every single back and forth, but I'm, we're trying to be a little bit more comprehensive. And so we're waiting for something definitive where we can go, okay, here's what's actually getting canceled. Here's what's being lost. Here's where people are being laid off. And so,
And it's
yeah.
interesting to see how the various news stories are changing. My favorite, well, that's not how I would have reported that, is one of the reasons that Butch and Suni, whose last names both begin with the letter W, and one of them is Williams. I'm so sorry. I have
Cindy
forgot.
Williams and Butch Whitmore.
Thank you. It's so not cool when all of the last names have a W involved. You can tell how my brain files information. Anyways, so they, along with the rest of the Crew 9 humans, had their return to Earth delayed because the Crew Dragon that just returned to Earth most recently is being retired, and a new Crew Dragon wasn't ready for delivery to NASA. And so, for lack of a NASA certified and configured Crew Dragon, they couldn't launch Crew 10 as planned. As it is, they're taking one of the other Crew Dragons that had originally been configured for space tourism. They're redoing it for NASA crew instead. But the current delays are entirely of SpaceX's own making. But you've seen Musk reporting it as they're stranded in space and the president is directing SpaceX to rescue them. No,
Right.
it's SpaceX is the reason they're still there. And this is
Well, I
admittedly
mean,
because
Boeing.
Boeing wasn't. Yeah.
Yeah. Like, I think, like, Starline has got to have some
So,
responsibility for
and
this.
the reason in part that there wasn't another Crew Dragon ready is there was an expectation that Starliner and Crew Dragon would together be ferrying astronauts back and forth, and they weren't prepared to have to make another Crew Dragon. Just wasn't on their list of things to do before 2030 when they deorbit. And what's fascinating is today you have Musk saying, let's just deorbit ISS as soon as possible. And so you have to ask what additional motivating factors are involved in that decision.
Yeah. Yeah. So, I mean, you are now starting to maneuver around a can of worms,
Yeah.
and so again, like and I appreciate you being measured in the things that you're saying. And for now, like this is all we know.
Yeah.
And I think a lot of people are and yet I think the writing is on the wall that things are about to happen, and the kind of chaos that we have seen in other parts of the administration and the parts of the federal architecture are about to hit NASA. And it is as chaotic as an asteroid coming within
Yeah.
a few thousand kilometers of the surface of the Earth and having a three-body interaction with the Earth and the Moon, and who knows what happens next.
And this is where I think it's important for people to remember that Artemis was originally pushed hard by Trump.
It was his plan to get people to the moon.
And science has historically always been funded much better by Republicans. And so it behooves everyone who can legally vote in the United States to call your Congress critters Democratic or Republican and tell them what you feel. And
Yeah.
I feel strongly they should fund science.
Yes. Yeah. I mean, I think hopefully this is something that people can agree is that the United States is a beacon of scientific research around the world. It is the most influential scientific research group that has a country that has ever existed in the history of humanity. It contributes more to science than any other nation. And yet that has overnight turned into chaos, and the outcome is that people who are new graduates of universities around the
Yeah.
world are gonna go like, do I want to go and do my science in the United States, or do I want to go to
No.
Europe, or do I want to come to Canada?
Well,
People who are attempting
it's
to make proposals for scientific research within the US again are going to go like, would this make more sense for me to take this to China, where they graduate, I think, 20 times as many STEM scientists as the United States does.
and there are already people who are having their graduate fellowships canceled on them.
Yeah.
So we're getting ready to go to graduate school next year and are being like, nope, we're sorry, we can't fund you.
Yeah.
As funding opportunities go away, as overhead funding goes away, as opportunities go away. And it is the people who graduated and chose service in the federal government who are losing their jobs among those probationary periods.
Yeah.
We're destroying a generation.
Yeah. So before we all get too emotional here, we will promise to provide you as accurate and unbiased reporting as we can about the situation and relay the facts to you as they come out, and we're able to tell you what's going on. And hopefully that in the end, this will not be as devastating as it appears to be lining up to be. Pamela, on that note, thank you for taking the time to chat. Thanks for encouraging us to not panic about an asteroid strike. Thanks to all of the moderators who came on a non-normal day. I see Zappin
Yes.
and John Ziffler here. Thanks, guys. And we will see all of you next week.